This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss some technology solutions and problem extensions for the 2018 AP Calculus exam, Free Response Question BC2. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. And I'll focus on or highlight the solutions presented in these guidelines, not how the points were awarded. This question was calculator active, so I'll show you how to use technology to explore and answer parts of this question, and to confirm solutions, where appropriate. And because the free response questions are usually very comprehensive, I'll suggest some problem extensions. These are additional AP Calculus type questions associated with the information given in the problem. And some of these questions may be calculator active. This question involves plankton cells in a sea. We are given a function that models the density of plankton cells at a depth of h meters for h between 0 and 30. And for h greater than or equal to 30, the density is modeled by an unspecified function f. In part A, we need to find p prime of 25, and using correct units, interpret the meaning of p prime of 25 in the context of the problem. In part B, we consider a vertical column of water with horizontal cross-sections of constant area 3. We need to calculate the number of plankton cells in this column of water between h equals 0 and h equals 30. In part C, a larger column of water is considered, and a new function u is introduced. And we need to write an expression involving one or more integrals that gives the number of plankton cells in the entire column. And we need to explain why the number of plankton cells in this column is less than 2,000 million. In part D, information about the position of the boat is given, and we need to find the total distance traveled by the boat over the interval 0 to 1. Part A was worth 2 points. 1 point for the correct answer, minus 1.179, and 1 point for the meaning of p prime of 25 with the correct units. And this point really involved 4 items. The student must refer to 25 meters or indicate a depth of 25. They must use the word rate. They must indicate this value is associated with the density of plankton cells, and they must indicate the units. Part B was also worth 2 points. 1 point for the correct integrand in the context of a definite integral, and 1 point for the correct answer. Now the question asked for the number of plankton cells to the nearest million, so we're looking for 1675 here. But any answer that is correct to the number of given decimals, up to 3, earns this point. Part C was worth 3 points. The first point was for writing an integral expression that gives the number of plankton cells in the entire column. And we really need 2 separate integrals here, one involving the function p, and the other the function f. The second point was for comparing the integral involving f with an improper integral involving u. And the third point was for the explanation, that is, why the number of plankton cells in the column is less than or equal to 2,000 million. Part D was worth 2 points. 1 point for the integrand. Note that the student can and should use the function names here, x prime of t and y prime of t. There is always a risk of a copy error in writing out the actual expressions for x prime of t and y prime of t. And there was 1 point for the total distance traveled, computed using a graphing calculator. Here's how we can use technology to solve Part A. Using a TI-Nspire, I first defined the function p, and then I simply found the first derivative and evaluated this expression at h equal 25. And here's an interesting result that was presented by some students who used a CAS graphing calculator on the exam. See if you can figure out where the 0.997503 comes from. In Part B, we need to find the number of plankton cells in a column of water. Conceptually, the student needs to set up a definite integral involving the cross-sectional area and the density of plankton cells. Once we have the definite integral, the final answer is pretty straightforward using technology. Again, using a TI-Nspire, I simply evaluated this definite integral. And rounding to the nearest million, the answer is 1675. The work in Part C is mostly conceptual, and there isn't much that a graphing calculator can add to the solution. However, here are several related problems that involve technology. Let's suppose the density of plankton is modeled in the same way as given in the free response question, by the functions p and f. First, find the maximum density of plankton cells for h between 0 and 30. In Part B, consider a vertical column of water with cross-sections of area pi times the square root of h at a depth h. Determine the number of plankton cells in this column of water between h equals 0 and h equals 30. In Part C, find a depth d such that the number of plankton cells in this column of water is 6,000 million. And in Part D, let's consider the column of water that was described in the free response question with cross-sections of area 3. And suppose the function f is defined by f of h is equal to h divided by 30 times p of h. Determine the number of plankton cells in this column of water between h equals 0 and h equals 60. Part D really involves finding the length of a curve defined parametrically. And once we set up the correct definite integral, we can use a graphing calculator to find this answer. So using the TI-Nspire, I defined the functions x prime of t and y prime of t. And then I evaluated the definite integral that yields arc length. The total distance the boat traveled over the time interval 0 to 1 is 757.456 meters. Here are two more problems that involve parametric equations and arc length. Graph each curve described by the parametric equations and find its length. I hope this video gives you some good ideas for additional practice AP Calculus exam type questions and of how to use technology to solve some of the parts of this problem, to explore, confirm, and visualize results. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.